Assalamualaikum and have a good day to everyone, especially to my lecturer, Dr. Azwin. Okay, today me and my group want to present about steam power plant. Okay, before that, I will introduce my name. My name is Nur Ishraq bin Zakwan and my metric number is 01DPU21F1072.
Yeah, hi. So my name Azfar Hakimi bin John. My metric number is 01DPU21F1065.
Assalamualaikum to Puan Azwin. My name is Muhammad Warif Faizal bin Wahid. My matrix number is 01DPU21F1057.
Hi, Assalamualaikum Dr. Azwin. My name is Nur Afika binti Ishaq. My metric numbers 01DPU21F1062.
Okay, first thing first, I will explain to you guys about introduction of steam power plant. Steam power plant give a big opportunity for productive work of various industries for over a century. Their importance in their ability to efficiently convert thermal energy into mechanical work, which can then be used to generate electricity and provide heat for various industrial processes. Here are some key reasons why steam power plants are crucial in various industries. Okay, first, electricity generation. Steam power plants have historically been a cornerstone of electricity generation. The basic principle involves heating water to produce steam, which drives turbine connected to generators. This process converts thermal energy into electrical energy on a large scale. Steam power plants provide a stable and reliable source of electricity, making them indispensable for meeting the power demand of industry and communities. Okay, the second key reason why steam power plants are crucial in various industries is energy conversion. Steam power plants can use various fuel sources including coal, natural gas, oil and biomass to produce steam. This versatility allows industries to choose the most cost-effective and environmentally friendly fuels, helping to reduce energy costs and environment impact. Okay, for the last reason, industrial processes. Many industries rely on steam for their manufacturing processes. Steam can be used for heating, sterilization, drying, and powering machinery in industries such as food processing, paper, pulp manufacturing, chemical production, and textile manufacturing. Steam power plants are essential for ensuring a reliable supply of steam for these critical processes.
Now, I will talk about key component of a steam power plant, outline the layout and the main component, emphasizing their function in electricity generation. A steam power plant consists of several key components that work together to generate electricity. Here's an outline of the layout and main components along with their functions in electricity generation. Firstly, boiler. The function of boiler is to generate high pressure steam by heating water using a fuel source such as coal, natural gas, or nuclear energy. The layout of the boiler is typically located at the heart of the power plant. The boiler contains the furnace where combustion takes place and tubes or coils to transfer heat to the water. Second, turbine. The function of turbine is to convert high pressure steam into mechanical energy. The layout is positioned downstream from the boiler. The turbine consists of multiple stages of blade attached to the shaft. As steam passes through the blade, it causes the shaft to rotate. Third is generator. The function of generator is to convert mechanical energy from the turbine into electrical energy. The layout is coupled to the turbine shaft. The generator houses coil of wire within a magnetic field. The rotation of the shaft induces an electrical current in the coil, generating electricity. Number 4, condenser. Function of the condenser is to condense the exhaust steam from the turbine back into water. The layout is located downstream from the turbine. The condenser uses cooling water from nearby source such as river or cooling tower to reduce the temperature of the steam, turning it into water. Number 5 is pump. The function of pump is to return condensed water from the condenser to the boiler, maintaining a continuous water steam cycle. The layout is positioned between the condenser and boiler. The pump increases the pressure of the water to prepare it for re-entering the boiler. Number 6 is cooling system. The function of cooling system is to manage the temperature of various components, including the condenser and the generator. The layout may include cooling tower, cooling ponds, or other heat exchange system to dissipate excess heat generated during the power generation process. Number 7 is fuel supply and handling. The function is to provide the necessary fuel to the boiler for combustion. The layout is fuel may be delivered and stored on site, then transported to the boiler as needed. Number 8, control system. The function of control system is monitor and regulate the operation of the entire power plant, ensuring efficiency and safety. The layout is distributed throughout the plant. Control system use sensor and feedback mechanism to manage the steam pressure, temperature, and other critical parameters. Lastly, these components work together in a steam power plant to convert thermal energy from the combustion of fuel into mechanical energy, ultimately into electrical energy, which can be distributed to homes and industry. This process is the fundamental method for generating electricity in many power plants worldwide. That's all from me. Thank you.
Next is point 3, safety inspection in boiler tube and drums. Safety inspection in boiler tube and drum are of paramount importance in ensuring the safe and efficient operation of boiler in various industries. Boilers play a critical role in providing thermal energy for a wide range of applications, including power generation, heating, and industrial processes. However, prevention is better than cure. Significance of safety inspections is prevent accidents and hazards. Regular safety inspections help identify and mitigate potential issues that could lead to accidents, explosions, leaks, or fires, thereby preventing harm to personnel and damage to equipment. Next, for the second, compliance with regulations. Adhering to safety inspection protocols ensures compliance with industry regulations, codes, and standards set by organizations such as the American Society of Mechanical Engineers and the National Board of Boiler and Pressure Vessel Inspectors. The third safety inspection is extend equipment life. By identifying and addressing problems early on, safety inspections can help extend the operational life of boiler, tube, and drums, reducing the frequency of repairs and replacements. Next is optimized performance. Regular inspections allow for the identification of inefficiencies and deviations in boiler operation, enabling adjustments to enhance performance, energy efficiency, and cost effectiveness. Okay, for the last self-inspection is maintain productivity and reliability. Properly maintained and inspected boiler tubes and drums ensure consistent and reliable operation, minimizing downtime and maximizing productivity. For common issue to consider in safety inspections is corrosion and erosion. Boiler tubes and drums are susceptible to corrosion and erosion, which can weaken the structure and lead to failures. Inspections should focus on identifying signs of corrosion and erosion and assessing their severity. Next is scaling and deposits. Accumulation of scale and deposits on boiler surfaces can reduce efficiency and obstruct heat transfer. Inspections should assess the extent of scaling and determine the appropriate cleaning and maintenance procedures. While the third common issue is well quality. Wells in boiler tubes and drums are critical for their structural integrity. Inspections should evaluate the quality of wells to ensure they meet specified standards and are free from defects. Than that, pressure and temperature variances. Monitoring and verifying pressure and temperature levels are within safe operating limit is crucial to prevent overpressure incidents or excessive temperature conditions that could compromise boiler safety. Okay, the last point for common issue is tube thickness and integrity. Checking the thickness of boiler tubes and assessing their integrity through non-destructive testing method are essential to identify thinning or weak areas that could lead to failures.
Yeah, so today I want to present about differentiation, fire tube boiler and water tube boiler. So first differentiation is heat transfer. Fire tube boiler, heat is transferred through the wall of the tube to the water surrounding them. Water tube boiler, heat is transferred from the hot gas to the water inside the tube. So the next differentiation is pressure. Fire tube boiler typically used for low to medium pressure application. Water tube boiler suit for high pressure application such as power and generation. So the next of differentiation of water tube boiler and fire tube boiler is safety. Fire tube boiler, lower water volume makes them portionally less safe in the event of the rupture. Water tube boiler generally considered safe due to the smaller quantity of the water and the ability to contain high pressure stem for effectively. Yeah, so advantage fire tube boiler, simplicity. Fire tube boiler are relatively simple in design, making them easy to install and maintain. Compact size. They are compact and suitable for small to medium size application with space constraints. Quick steam generation. Fire tube boiler can start producing steam rapidly due to their smaller water volume. Lower initial cost. Typically, fire tube boiler are less expensive to purchase and install. Suitable for low to medium pressure. They work well for applications that don't require very high pressure. So disadvantage for fire tube boiler: lower efficient. Fire tube boiler are generally less efficient because they have a smaller heating surface area, less responsive. They are slower in responding to sudden change in steam demand. Limited pressure, not suitable for high pressure application such as power generation. Portion safety concern. In the event of a temperature, the hot gas can escape into the surrounding. Water tube advantage: high efficiency. Water tube boiler have a large heating surface area, making them more efficient. High pressure capability, suitable for application requiring high pressure step, such as power generation. Quick response: water tube boiler respond quickly to change in steam demand, making them ideal for variable load application. Better safety: they are generally considered safe due to the ability to contain high pressure steam. Flexible design: water tube boiler come in various configuration and can be adapted to different needs. Disadvantage: complex design. They are more complex in design and construction, which can make them costly to manufacture, install and maintain. Large size: water tube boiler are large and may require more space. Slow startup: they take longer to start producing steam due to their large water volume. Highest initial cost: typically, water tube boiler have a high initial cost compared to fire tube boiler. Heat saving instrument: superheater. Superheater raise the temperature of steam beyond its saturation point, increasing terminal efficiency by preventing moisture in the steam, reducing turbine erosion, and improving heat transfer in the boiler. Economists recover heat from the flue gas leaving the boiler and use it to preheat the feed water before it enter the boiler. They reduce the amount of energy required to raise the water to the desired steam temperature, thus improving overall efficiency. Condenser cool the exhaust steam for the turbine, converting it back into liquid water. This allows for more efficient use of steam, as it can be pumped back into the boiler and higher pressure, reducing the need for additional energy input. Turbine regeneration: in some systems, steam extract from the turbine is used to preheat the feed water of the other fluid, reducing the amount of heat required from the boiler and increasing overall efficiency.
Steam power plants are subject to various regulation and safety procedures to ensure the safety and efficient generation of electricity. Here an overview of some essential aspects. Firstly, boiler and pressure vessel regulations. Steam boilers are subject to strict regulations regarding design, construction, operation, and maintenance to prevent accidents due to overpressures or other failures. These regulations often include periodic inspection and certification of equipment. Secondly, water quality control. Water quality control, proper water treatment is crucial to prevent corrosions and scale formation within the boiler. Regulations mandate strict water quality standards to maintain the integrity of boiler and ensure efficient heat transfer. Thirdly, safety valve. Safety valve is steam boilers are equipped with safety valve that automatically release excess pressure to prevent explosions. This valve must be properly maintained and tested regularly in compliance with safety standards. Fourth, emergency shutdown procedures. Steam power plants have well-defined emergency shutdown procedures to handle critical situations. These procedures cover equipment shutdowns, isolations of steam sources, and evacuations plans for plant personnel. Fifth, lastly, combustion safety. Regulation require the safe operation of fuel system to prevent explosions, fires, or other hazards. This includes measures to control fuel air radius, ignition sources, and proper ventilation.